Okay, today we are going to be doing our first experiment, and we are going to be experimenting versus two different percentages of alcohol, and we're going to see what the reaction is when we ignite them both. It's a nice introduction into scientific method. It's also a chance for you to blow some stuff up, which is always a positive, but make sure we're always safety first. So, we are going to take this is a 70% solution of isopropyl alcohol. So the rest of it is another mixture. And we need exactly 20 milliliters. All right, so that is 20 milliliters. We're going to cap that. Make sure we're good to go. Now, back up. There we go. All right, sorry for that. So what we're going to do is I'm going to pour the 70% solution into the 5-gallon container. I'm going to set my timer, and I'm going to shake it for 1 minute, and then we'll ignite it and see what the reaction is. So, starting to cut in front of the camera. I'm going to go ahead, add the fluid. And we are going to start the timer. So, what I'm doing now is I'm mixing that alcohol with the air inside. Because if we know anything about flame, it needs 3 things. Anybody know what those 3 things are? I'll give you a second to try and figure it out. Well, I'm adding air, so air is one of them. We have the alcohol. That is the fuel source, so something that's got energy enough to burn. And then the last part is the ignition source. So in about 25 seconds, we're going to go ahead and use this ignition source. So I'm going to turn this all around. I'm going to really make sure that the air and the fuel mix up. I really don't want any more liquid fuel around. If I can help it, when this timer goes off, I'm going to turn off the lights, and we're going to see the reaction of the 70% solution. All right, and that is the timer. So, 70% solution, 1 minute. Okay. That was 70% at 1 minute. Now, we are going to take the 90%, so that was 70%. Now we need the same 20 milliliters. The volume of liquid has to be the same. I don't want that to be a factor impacting my experiment. I'm using the same size bottle. They're both 5 gallons. Okay. Now I want to make sure that my timer's good to go, and it is. So now I'm going to add my 91% solution. Start my timer, and I'm going to start to shake. And again, now a couple things I want you to notice different about the 2 trials. Is there any specific way that I'm shaking it? Am I counting how many times I'm shaking it? If you go back and watch this video, you'll see that I'm not. I'm just kind of randomly doing it. I didn't do this before. So I'm just trying to include air as best I can. This is a 90% solution, 91. So we're going to see this is a better reaction. At the end, I will add one more variable and see how that impacts it. Because we always want to talk about what other things can we experiment with. So my timer is about 20 seconds. So again, I'm mixing that air in, and I would have to apologize if this entire video is crooked as I'm looking at my camera. It looks a little off center. I don't know if that's something I can fix in post or not. Otherwise, you're just going to look at me slanted. It's the first video. What are you going to expect? All right, so that is my timer. So we're going to take our 91% solution, after 1 minute. All right. Now, different reaction, I would say. Different factors you want to quantify. Now, one thing that you can't do at home is you can't smell. Now, I'm sure you can smell, but you can't smell what I'm smelling here. And that is that there's a distinct alcohol smell in the air, which means that the particles that spread around through the air. So it's a distinct difference between the two trials. Now, we're going to do one more, kind of a bonus. We're going to do one bonus. I apologize for turning my back on you. We're going to go for 2 minutes and see if the amount of time that we stir it makes a difference. Now, I'll use the 91% solution again. Why? Because it's 91%, and I think it's a better reaction. And if you're going to blow something up, blow it up right. I will put a disclaimer on these videos for parents that please don't try these things at home. All right, so this is going to be 91% solution. Now, you saw the last reaction. I want you to see how it impacts with this one with a longer time. So this, the variable, is the amount of time that I'm going to mix it. So we're going to start our timer. Now this time we're going to go for 2 minutes. Now, I got to make sure that air is really put in this time, because the last time I used this bottle, I didn't really air it out and clean it out. All the air was used up in that last reaction, so I really have to make sure that I get enough air in this to mix with that fuel. I really don't have any liquid fuel left. It's never the liquid fuel that burns, it's the mixture of the air and the particles that really cause a reaction. Now, when we talk about engines and cars, we'll see how it relates to that. That's why I love this experiment. Not like to blow stuff up, but it's really kind of a cool introduction into combustibility, particles, how we make chemistry, chemical changes, chemical properties, chemical reactions. So, another thing that you couldn't notice that you from home as this being a demo is that afterwards, before I did this, the bottles were room temperature. After I ignited did both reactions, the bottles were warm to the touch. Not hot, but warm, which you would expect because they were just previously on fire. Now I'm also noticing that this bottle needs to be retired. This old soldier has a crack in it. And if you go back to safety, you should realize I shouldn't be using this bottle because it has a crack in it, but I'm a professional. I'm wearing my goggles. So what could go wrong? If so, this video is going to be a record of it, so you guys make a lot of hits on Fail Army or something. All right, 20 seconds left. So you can see this is a lot more time. If I make this into a video or I create this, I'll probably put some music behind it, so you don't have to listen to me the whole time. 10 seconds. All right. This is going to be after 2 minutes. So the only variable this time is still 91%, but it was 2 minutes of stirring as opposed to 1. Let's see if that made a difference. So, if we go to match, we can see the difference. All right, so I will let you judge from that reaction what was the better type. Now again, warm to the touch, distinct alcohol smell. Otherwise, that is the experiment. We'll touch base on it later on. Otherwise, have a good rest of your day.